is lost. Be the future, to pay the cost. You will there ever be a second time around?
All right, guys. Hey, welcome to our first video lesson for Chapter 3. There was a little 90s sitcom called Step by Step with the Code Man, dude. Or probably way before your time, but hey, based out of Port Washington, Wisconsin. Kind of interesting, hey? So, all right, so with this chapter, we're going to look at solving equations. I'm sorry, I can't talk today. This lesson, we're going to focus on just simply solving one-step equations. So let's jump right into it. All right, so what we're going to talk about today is solving one-step equations. And again, coming into this class, you probably have some background knowledge on how to do this. So I'm not going to go through each of these in detail, but the key thing about solving equations, again, the equation is when we have two expressions separated by an equal sign. For example, 2x plus 1 equals 4. And our goal is to figure out through some operations on how to figure out what value of x. What is the value of x that makes this equation true? So we're going to try and figure out what is the solution to this equation. Now to do this, what we're going to do is what's called an inverse operation. What an inverse operation really is that when we see something being done to the variable x, when we see something like plus 1 or times 2, we are going to do the inverse operation to get x isolated, to get x by itself. Inverse means the opposite. So if I see that I'm adding, I'm going to subtract to get rid of it. If I see that I'm multiplying, I'm going to do the inverse or the opposite, which is to divide. Okay? What we're going to make use of is basically these four properties here: addition, subtraction, multiplication, and division. With what these basically say, and I'm not going to go through each one in detail because I expect you to kind of remember these, but I'll go through one of them, for example. And let's say addition. What this says is that if I take, let's say, x equals 2, and I decide, for some reason, to add 2 to one side of the equation. Now, in order to keep something equal, here's what all of these properties say. Whatever you do to one side, you must do to the other side. So if I add 2 to one side, I have to add 2 to the other side. If I subtract 2 to one side, I have to subtract 2 to the other side. If I multiply by 2 to one side, I have to multiply by 2 to the other side, and the same thing goes with division. If I divide by 2, I must divide by 2 on the other side as well. So all these properties say is whatever you do to one side, you have to do to the other. That's what makes an equation true. Okay, so we're going to apply these properties to what are called inverse operations. So again, inverse simply means the opposite operation. Okay, operations, what are these? Operations are addition, subtraction, multiplication, and division. Okay, those are the basic four that we're going to look at in this chapter. All right, so if we take, for example, if we see that we have addition. So let's say, for an example, I have x plus 2 equals, 4. And I want to get x by itself. What I'm going to do is do the inverse operation. Notice I am adding 2 to x. So to do the inverse, I'm going to do the opposite. I'm going to subtract 2 from x. What is that going to do on the left side? Well, plus 2 and minus 2, that's going to get them to cancel and leave x by itself. But what I'm going to do then is I'm going to subtract 2 to the other side as well. Because the property of subtraction tells me if I subtract to one side, I must do it to the other side. Okay? And what that's going to do is it's going to tell me that x must equal, 4 minus 2 is 2. And boom, I have solved an equation. So what I did here is used an inverse operation where I saw addition, I subtracted. So for the rest is going to follow. If I see subtraction, I'm going to do the inverse, which is addition. If I see multiplication, I'm going to do the inverse, which is division. And if I see division, I'm going to do the inverse, which is multiplication. So you have to recognize what is being done to the variable, and you are going to do the opposite operation on it. All right, so we have here 6 examples. Let's go through them each in detail. So first of all, we're going to just try and look at the equation and figure out what is being done to x. Okay, first one we have x plus 3 equals 12. Let me zoom in a little bit. I have x plus 3 equals 12. So the first thing I just recommend to do is we have to recognize where the equal sign is. So what you may have learned before, and what I kind of like to do, is let's put a little dash bar along the equal sign. Because what we're going to do is we're going to try and move things and isolate the variable x. We're going to try and get x by itself. So first thing I'm going to look at is what is being done to x. Well, I see that I have x plus 3, so I'm adding 3 to x. So if I want to figure out what x needs to be, and some of you might be able to mentally, and we did this in chapter 1, might be able to think through it and think about what x is going to be or what it needs to be. But we can solve for it by doing an inverse operation. So what's the inverse or the opposite of addition? Well, it's subtraction, kind of like the problem we just talked about. But here's the property of subtraction. If I subtract from one side, I must subtract from the other side as well. And what does that do? Well, on the left side, positive 3 minus 3, that cancels out. Okay, and what am I left with? Well, the only thing left over on the left side is x. And equals, well, 12 minus 3 is 9. Okay, so what I get as an answer is x equals 9. Now, the next step I'm not going to require you to do. I'm not requiring you to do this, but it is very helpful. And that is to take your solution of x equals 9 and to check your solution. What does it mean to check your solution? Well, what you're going to do is you're going to take 9 and you're going to plug it back into the original equation. So I'm going to have 9 plus 3. And my question is, if I check my solution, if I plug it back into the equation, think back to chapter 1. If I plug x in for 9, and I want to see if this equation is true, remember that both sides have to be equal. So here, 9 plus 3 is 12. Does that equal 12? Well, yeah. Boom. So I checked my solution. I know that it works. If you ever check your solution and you know your answer doesn't work, well, that means you did something wrong throughout your solution. All right. Here we go, number 2. We have w over 3 in fractional form equals 12. What is it, when I write something as a fraction, what does that mean mathematically? Okay, something we get confused with at times. Well, this represents division. Okay, so when I have w divided by 3, this represents division. So if I want to get w by itself, again, here's w, I want to get it by itself. If I'm dividing by 3, in order to get rid of that, I got to do the inverse operation. So what's the inverse of division? That is multiplication. So I'm going to take and multiply this by 3. Okay? Now what happens when you multiply and divide by 3? That is going to cancel out. So the whole purpose here again is that we are trying to get the variables to cancel. And I forgot to put my little dash bar along the equal sign so I can see where I'm going. But we'll do that here. And then I'm going to take, and if I multiplied 3 on one side, I have to multiply by 3 on the other side. So I get 12 times 3. So what you're left with then is w on the left equals 12 times 3 is 36. Okay? And again, we can go ahead and check our solution. If I plug in 36 back into my equation, I get 36 divided by 3 equals 12. Well, what's 36 divided by 3? That's 12 equals 12. Check, my solution works. Okay? All right, moving on. Now, number 3, a little twist here, a little spritz of lemon here. But I got g on the right side. Does it matter if I have my variable on the left side of the equation or the right side? And the answer is no. So I give you this problem because g is on the right side of the equation, but it doesn't make a difference. What we're going to do is look at what is being done to g. So I have g minus 5.2. So I'm subtracting 5.2 from g. So if I want to undo that, I am going to add 5.2 to g. Okay, I'm going to do the inverse operation. That's going to get this to cancel, but again, if I do it to one side, I have to do it to the other side. So I'm going to add 5.2 there. Now I'm adding decimals, so 3 plus 5.2 is going to give me 8.2, and that's going to equal g. Now 8.2 equals g. Does that say anything different to g equals 8.2? No, it does not. Okay, this is known as the symmetric property of equations. It says that if you say x equals 8.2 or 8.2 equals x, they say the same thing. So here is my answer. Okay, and again I can go ahead and check. Does 3, is it equal to 8.2 minus 5.2? Well, if you're not good with subtracting decimals, punch it into a calculator, and you should see that 3 certainly does equal 3. So boom, again, checking our solution. Not necessary, but sometimes it does help. All right, so let's continue on. I got 3 more examples here. Let's see if we can do this rather quickly. So again, I could put P on the right side here, variables P. That doesn't make a difference. I'm going to put my dashed line through my equal sign. All right, just helps me to show one side and the other. Now, notice I have P on the right side, but you're going to get this a lot when you simplify equations. You're going to be left with negative P or minus P. So we have to think back from last chapter. What is the number in front of P when I say negative P? Well, remember, how many P's do I have here? Yeah, it's negative, but how many P's do I have? I have 1, so this really represents negative 1P. So what am I doing to P? Well, I have negative 1P. That means I am multiplying by P. So this is one thing you have to remember. When you see negative P, you have to simplify this. How do I do that? Well, I'm multiplying by negative 1, so to do the inverse, I'm going to have to divide by negative 1. Now, when I do division, I like to write it as fractional form like I did here. So I'm going to divide by negative 1, boom, over there. That's going to cancel that out, right? Negative divided by negative is going to give you a positive 1. And I'm going to take and divide over here by negative 1 as well. And what's 23 divided by negative 1? Well, all that gives you is negative 23. But now on the right side, I have P isolated. So with this problem, key thing, we have to make sure that we get rid of all the negative signs. P or the variable, whatever it may be, has to be isolated without any numbers, any signs, anything like that. All that has to be gone. We just want the positive variable left behind. Okay? Ooh, 2 more examples, and Pescadios. We have ourselves fractions. Oh my gosh, why do I even do this to myself? Well, it's okay. Remember, we have to be able to work with fractions. So this one I have 2 over 3 plus x equals 2. Okay? Now written a little differently, but nevertheless it's perfectly fine. I have 2 over 3 plus x. What am I doing with this? What am I doing with 2 over 3? Well, I'm adding it. So I want to make sure to get it to the opposite side. I'm going to do the inverse, which means I'm going to subtract 2/3 x. Or 2/3, sorry. That means I'm going to subtract 2 over 3 over here. I'm going to write this down in the bottom, so follow along. Now what we have is 2 minus 2 over 3. So we have to remember from chapter 2, last chapter, on adding and subtracting fractions. Right now this is 2 over 1, so when I add and subtract fractions, I have to find a common denominator. Do they have one? No, I have 1 and 3 as my denominators. It means I have to get the same one. So I'm going to express both of them with a denominator of 3. Okay? Because 1 and 3, that's the least common multiple between those two numbers. Okay, the 2/3 at the end, that's not going to change because I didn't change the denominator, still 3. But the 2, what did I do to get from 1 to 3? Well, I multiplied by 3, so I'm going to do the same thing on top. So 2 times 3 is going to give me 6. Basically what I'm saying is 6 over 3 is equivalent to 2 over 1. If you were to check that and simplify, that's true. Now I can go ahead and subtract. So 6 over 3 minus 2 over 3 is going to equal 4 over 3. Remember, all I do is subtract the numerators and I leave the denominator the same. So what does that give me in the end? I know that we did the work down here, but this shows me that x is equal to 4 over 3, and I can leave that as an improper fraction perfectly fine. Okay? If you want, again, what can we do at the end? If you're not sure if this is right, check your solution. 2 over 3 plus 4 over 3, does that equal 2? Okay, well, what's 2 over 3 plus 4 over 3? That's going to give me, I'll write it on the side here, I apologize, run out of space, 6 over 3. Well, 6 over 3 is equal to 2, right? Because 6 divided by 3, if I simplify this, gives me 2. And therefore, 2 equals 2. Boom, I have checked my solution. Okay? And then last problem here, last one with a fraction, we have negative 2 over 3 times x equals 1 over 3. So what you have to ask yourself again, okay, here's my equal sign. Separated. What am I doing with negative 2 over 3 next? When they are written next to each other, what does this tell me? This tells me that they are multiplied together. So what I'm going to do to get rid of it is I'm going to divide by negative 2 over 3. Okay, let me rewrite that. I kind of wrote that sloppy. So I'm going to divide by negative 2 over 3. And I'm going to take over here and I'm going to divide. I'm just going to write this a little differently. I'm going to take and divide this by negative 2 over 3. Okay, that's going to get this one again. Inverse operation. This is going to cancel out. Right? And you're going to get x equals, but let's rewrite this on the side. What I have is 1 over 3, and I'm going to write it a little different, divided by negative 2 over 3. Okay, why did we go through all that stuff last chapter about working with real numbers? Well, this is why. What do I do when I divide fractions? I have 1 over 3 divided by negative 2 over 3. Well, the rule I gave you is we are going to take and multiply by the reciprocal. So what's the reciprocal of negative 2 over 3? It is negative 3 over 2. Take the fraction and flip it. Don't change the sign, but just flip it. Okay? Now we're multiplying fractions. Again, what can we do is simplify. 3 goes into itself once, and a negative 3 once. Okay? So what I'm left with is, I'll rewrite it, x equals 1 over 1 times negative 1 over 2. I can multiply those together. X equals negative 1 times 1 is going to be negative 1. 1 times 2 is going to be 2. So I get x equals negative 1/2. Okay? So we have to be able to apply our rules of real numbers from last chapter and be able to solve these one-step equations. All right, let's polish this video off with one application problem. So I have an American flag has an area equal to 9.5. This represents right here square feet. Square feet, SQ means square. While the length is equal to 1.9 feet, and it says find the width. Okay, so what we have here is our dreaded word problem, right? So when we have a word problem, we got to just think about, first of all, what I like to do is let's circle some of the things we're given, okay? I am given 9.5 square feet. Well, what is that? What does that represent? Know that that gives you the area. And it tells me that the length is 1.9 feet. And what am I trying to solve for? My goal is to solve for the width. Okay, so when you're given word problems, it helps to kind of circle the things you're given and to really think about the problem and see what you're trying to solve. So what I'm trying to find is the width. And I know that I'm given the area and the length. Okay, so I know that length and width, hopefully you kind of have this knowledge, is related to area. A flag is really represented by a rectangle, right? Ooh, rectangle, I said that kind of funny. What's the area of a rectangle? The area is simply equal to the length of the rectangle times the width, where the length is the long side, width is usually the short side. Okay, so what I am given is I'm given the area of 9.5 square feet, the length of 1.9, and I want to find the width. So what can I do with that information? Well, notice here when I write this area formula, I have myself an equation. So all I got to do is plug in what I know. Well, I know that the area is 9.5 feet, or square feet. I know that the length is 1.9 feet, and I want to find the width. So now when I plug things in, I get myself a simple equation to solve. Now, what we have to do is think of inverse operations. Here's width. Just label it as W, right? What am I doing with the length and the width? Well, I'm multiplying them together. So to get the width by itself, I'm going to have to take and divide by 1.9. Do the inverse operation. That's going to cancel it out. But I also need to divide this side by 1.9 because the rule of division says if I do it to one side, got to do it to both sides. What that is going to give me is W is going to equal 9.5 divided by 1.9. Which, if you punch that into your calculator, because of decimals, you're going to get W equals 5. So it's going to tell you W equals 5 feet. Now, if you look at my diagram, you may be saying, well, hey, big dog, you said that this is the width, right? And on a flag, you wouldn't have a 1.9 feet here and 5 feet here. Yeah, it's okay. I mean, if you really look at this diagram, how we label length and width, usually left to right is length and up and down is width. Nevertheless, we solved it correctly. We know that the width is 5 feet. Okay? So with this one, read the problem, circle what you're given, and think about what you're solving for. All right, kids, I hope you enjoyed your first lesson of Chapter 3 on solving one-step equations. Good luck on the practice problems. We'll see you in class. Peace.